Hi, it's Gadget UK here again, back with this SNK power supply for the AES POW, I think it is. It's my own fault this, I should have investigated further. You'll remember from the previous video I did a little bridge fix there, because there was, as you can see, I've just pointed out with the probe there, you've got a blown, you can see that blasted track, there's one there now, and it's the same track again. This one loops around, goes the same way, so there's something wrong there somewhere. Now I've taken the cap off, the cap's okay, I can smell electrolyte, measured it, it's 120 microfarad, 400 volt, that's fine, there's no problems there at all. Now it could be the ESR, but yeah, that cap seems okay, but I could smell electrolyte, and I thought something else has gone on with this board here. Now I just inspected around here, and you can see some corrosion, and it was there previously, I just never spotted it. So of course, taking the cap off, and it's wet underneath, so that's what's happened. We've got some electrolyte, it's interfering with the transformer there, probably on both sides of the board. Needs cleaning up, and I suspect that's what's caused the problem here. Now the fuse didn't blow in this instance. I can only hope that this hasn't done further damage to the power supply and my AES is okay, but right now I need to swap out this cap. So it's 2200 microfarad 16 volt. I'll just measure this, just put on the cap meter here. I'm guessing it's going to be significantly different to 2200, so I'll put on a 20 meg range so that it'll read it. That's not, yeah, is it 2 microfarad? Or 2000, I'm not sure. Don't know, it's not reading. 2 farads, I think that's reading, because that's 2 meg maybe, because it's on the 20 meg range, I'm guessing. Yeah, so I don't know, this, yeah, that needs swapping out, so we'll do that anyway. I'll clean the board up and I'll check the other capacitor on there. Before I go inside this again, I just want to make a bit of a point here on safety. Whenever you're dealing with power supplies and things like this, be very careful. If you don't know what you're doing, just stay well away. But you know, you've got like these main ballast caps in here that will hold. I mean, this is marked 400 volts. The input that comes through the AC that comes in through the bridge rectifier, you know, it's rectified. And in part and parcel of that, when it's converted to DC, you know, the voltage, it's not 240 volts, it's 240 times 1.414 recurring. So ultimately, you end up with 300 odd volts on a 330 or 3, I can't remember exactly what it is off the top of my head. And these stay charged, you know, once the thing's powered up, it charges the cap, you switch it off, that cap will hold power for a certain amount of time. Sometimes you can leave, you know, connect it to a system, switch it on when the power supply is not connected to the mains, and you'll just see the power light come on and it'll drain it. I've mentioned that many times before, but that doesn't always work, and there's actually, these caps do recharge, they recharge themselves. If you watch some of Dave Jones's videos on EEV blog, I think he covered this recently. I forget the sort of term that describes it, but yeah, they will recharge, you know, so you see the voltage drop right down and you think it's, you know, it's dissipated, and then you disconnect it, and if you measure on a meter, you'll see the voltage going back up, you know, could go back up as high as 50, 60, 70, 80 volts, despite the fact you've just discharged it. So that's important to know as well. And you know, when you're working on things like this, just be careful, you know, obviously make sure you've isolated from the mains to start with. And you know, make sure you've not got any toddlers and pets and things around while you've got the board out and the caps hanging around and anything exposed. And I'd be tempted not to power this up without either wearing protective goggles and stay. You know, it sounds daft, but if you, I can't really show you, but you've probably seen previously there was blast marks in the inside of the lid here, copper all over the inside of the lid where the track's blasted, and this is what can happen with power supplies. So if you're just sort of, you know, be staring over this like this with the lid open now and power it up to see what happens, if a trace blows like that, you could be permanently blinded. You know, it could do some serious damage to your eyes. So, you know, this is why when I've done this, I haven't even had the lid off. You know, when I power it back up, I put the lid on first, even if it's not screwed on, power it up that way, and just be mindful of the fact that, you know, if the lid was off and I'm looking down on it when it's powered up, something could explode and blind me. So that's important to know. So I swapped out a couple of caps on here, replaced both of those caps. That one there, sorry, both of those caps, that one there was leaking, and the electrolyte had leaked all around this cap here and the transformer. So I think it's the electrolyte that's caused this, and you can see some corrosion up there. I'll just see if I can zoom a little bit. Can you see it's a little bit flaky, that area? That's where the electrolytes sort of, you know, start to eat away at the board. So one thing I'm going to do here, you'll see I've removed that piece of tape. I'm going to put a piece of hot glue in between that trace and the 3 pins of the transformer to isolate it. And I'm going to do the same thing where I've had to bridge the track here where it blew the second time. You'll see here between these 2 pins, because if there's not something on there that's going to seep all the way through to try, you know, it'll seep right into the gaps there, the tiny little gaps. There's a very high probability of something arcing from one of these 2 points here, and so I'm just going to put some glue around that whole area there. There's, it should be all right, you know. It's protected by a fuse. It's only hot glue. It's not conductive. It could heat up if something there starts to get warm, but it's not going to add to the problem, really. And this goes against what I've said previously about putting a lot of glue on solder points. On a power supply or something like this, it's not a problem. You can just peel it off. You're not going to damage the traces, and it's only going to be in a confined area anyway, just around that area there and this area here. And all being well, that should fix this. I think what I'll probably end up doing is plug this in somewhere like a garage or something where you've got a concrete floor. Connect something up to draw a bit of load. I'm not sure what I'm going to do with that yet. I'll find something, an old faulty console or something. I've got an old Amstrad GX or something. I might just connect that up to it or something, and just leave it on for maybe 24 hours or something, just to make sure that it's okay. I'll leave the meter sort of measuring the voltage level on there, just check it periodically. Hopefully that should do it. So as soon as the glue has warmed up in a sec, I'll heat that up. But you can also see I've swapped out the main ballast cap or whatever it is there as well. This one measures okay, but I just didn't want to take a chance, to be honest. I can't see what else it could be other than a leaky switching transistor, potentially, or maybe there's something's arcing inside that transformer, but I don't think so. I think, you know, there's usually, you know, it's cause and effect, and I think the electrolyte, you know, I think it's the electrolyte. The electrolyte, it's no surprise that that's there. And it's on the secondary side, so even though the primary side, you know, is the thing that's popped, it's no coincidence. You know, I always believe there's a reason behind these things, and I think that's probably what it is. So there we go. Not the cleanest of work, but you know, you can see still cooling down. Actually, on drying, I should say, solidifying. We've got a trail here, just isolating these 3 pins from that trace. And then this whole area is just a bit of a messy, mucky blob. But it's seeped down in between all the pins there, so the probability of it shorting at one of those points is minimised. I would hope if it blows again, it might blow here, because what tends to happen is it'll go for the thinnest. Well, there's a couple of things that go on here. The arcing, you know, when you get an increased, I don't know, it's a voltage level that raises or whatever, or that, you know, there's a propensity there for the currents to be quite high. It will try and take the shortest path to Earth, as far as I understand. So in this case here, I think the track just popped. You know, there was no there was nowhere that you could do that. It just blew. As soon as I fixed that, obviously it's blown here, and it will blow at the thinnest point, a bit like a fuse, really, in that sense. You know, the whole track is obviously taking 50% more current than it's supposed to do, so it will go at the thinnest point. And I think, in fact, in that case there, I think when it blew there, it arced across to here. That again, the electrolyte I think's caused that. But when it blew the second time, I think the electrolyte had leaked sort of around this area here. But it will go at the thinnest point. So I would think if it goes again, it's probably going to go at this point here, I would think. I just hope to God it doesn't arc anywhere else. As we've already seen, it's arced there. I'd hate for it to arc to one of these components here and destroy the switching transistor and some of the passives and things around there. You never know. So I'll reassemble it now and we'll give it a try. So here we go. It's plugged into the mains. No immediate pops or bangs or anything. I've measured the voltage here. There you go. Well, it's showing minus. I've got the polarity around on Y. These are outer positive, as I mentioned in one of my recent videos. Yeah, 5.5 volts roughly, and that will drop. You know, it's because it's no load. Once that's under load, it drops to just over 5 volts, like 5.05, 5.06, something like that. So I'm going to leave this powered up for a bit with nothing connected, and just check back on it in an hour, just to make sure it's okay. But yeah, hopefully that's fixed it. Thanks for watching. I'll see you soon.